In this video, I am going to explain about the basic performance equation. Okay, so we know that. So in my previous video, I told many times that whatever we user stores, all the programs and the files, everything we are storing in the secondary memory. And these programs all are written in some high level languages like C, C++, Java, .NET, Python, whatever. Okay, all these programs written by the user is in high level language. Now, whenever I want to execute any program, that program I need to shift to what? Main memory. So that will be done by the operating system. So once we brought the program what we want to execute into the main memory, then CPU can take from the main memory and can execute. Now the question is, how much time our CPU or the processor takes to complete the execution of one program? That is the performance. That means performance is a measure of how quickly our compiler or the computer, especially the processor, okay, performance is a measure of how quickly our computer can execute the program. Suppose if it is taking very less time, I can say my computer system is performing very well. Suppose it is taking more time, I say so it's not performing well. So that means the performance is nothing but it will indicate how fast it is executing our program. Okay, so that's what the performance. Now in order to derive the equation to find the performance, we need some parameters. So now with this diagram, so whenever we want to execute any program, so from some following steps we need to follow. Okay, so first we need to store in the secondary memory. Then from the secondary memory we need to bring into the main memory. That will be done by the operating system. That means it depends on what? First, your disk speed. That means whatever the hard disk, that hard disk speed is also matters. If it is very slow, then it is from taking from here on to take time. So first then the type of the operating system, that means how fast our operating system will brings into the main memory, and then that memory speed, that means main memory speed. Okay, main memory speed, how that is how from the main memory that it gives data to the processor. Okay, so then so CPU time. So okay, CPU time, that means how much CPU is taking time. Okay, so all then once CPU executes the program, again it has to store back the program data in the main memory, or it has to give the result in the monitor or some output screen. That means it is also displayed depending on the what? On output device speed, output device. So these are the factors on which performance of a computer depending on. So among these, we know memory speed. So in the last video I explained about how we can increase the memory speed. See, every time so processor going to the main memory and bringing that, so instead of that what it will do, our processor maintains one memory called cache memory within the processor only. Whenever it brings any instruction, it stores in the cache only. Next time whenever it wants the instruction, first it checks the cache. Suppose if it is present in the cache memory, then it will take no need to go to the memory, it will execute here only. Suppose that instruction is not present in the cache, then only it go to the memory and takes the data. So that means this cache memory is used to increase the memory speed. So this we discussed, right? So this we discussed, this is done. So now this is speed, this is not in our control, whatever the disk we are using, that only. Then operating system. So we cannot keep change operating system for one program. So once we will use whatever the operating system, that only we are using. So now we can check what is the CPU time. Okay, now we'll concentrate on the CPU time. Now, before that CPU time, now I'm going to explain one more circuit called processor circuit. What is this processor circuit means? Each and every electronic embedded system should have one circuit called processor circuit. Every system should have. So what this processor circuit will do, this processor circuit keeps generating some signals. Okay, how our heart keeps beating. Okay, so every 24/7 without taking any rest. Okay, it keeps generating the signal, heartbeat. Similarly, so one circuit is there within the processor of every electronic embedded system. That circuit keeps generating some clock signal. We call clock signal. So the signal is something like that. So I think you people know. So this is like this on clock signal. Okay, like this clock, it keeps generating continuously without stop. Once If the circuit stops generating this clock cycle, our system is gone. So whenever you take any computer, so whatever laptop, so you get some warranty guarantee, right? So that warranty guarantee is given to this circuit only. So that means as long as the circuit is generating this one, this is fine. Once it stops generating this signal, it's done. Okay, so this circuit keeps generating this clock signal. This is called clock signal. So spares. Okay. So we know that what? We know that in the same way this is one positive half cycle and this is one negative half cycle. Okay. Now this is the width of one positive half cycle and negative half cycle. This is what one clock cycle. Similarly, when come to this one, so I will say this is one positive half and this is one negative half. Okay. Now this I will call it as one clock cycle. This is called, I will call what? One clock cycle, and width of this clock cycle is a P, period. So one period, or the clock period I will say. Okay, P, you can use any name. Okay, there's a naming convention. This is what one clock period time. So the importance of clock, how much the width is more, this clock period, that much our system is slow. So that means, for example, I think when you buy your system, you can know the speed of the CPU. So when you take some our mobile, so generally it is what? 2.4 gigahertz. 2.4 gigahertz means 2.4 into 10 to the power of 9 hertz. That means 2 to the power of 4 followed by 9 zeros. This clock cycle, this is one clock cycle. This is two clock cycle. Like that, these many clock cycles which are in 1 second. That means whenever our processor is doing any operation, it has to complete one operation in one clock cycle. Suppose, for example, our processor circuit is generating 100 clock cycle in 1 second, means our system can be able to do only 100 operation in 1 second. But if our processor circuit is generating like this clock cycles, 1000 clock cycles in 1 second, means our processor can execute 1000 operation in one clock cycle. But think 2.4 10 to the power of 9, that means so 2.24, now it is 1, 2, 3, 4, 5, 6, 7, 8. So these many clock cycles will generate in 1 second. That means these many operations can be done in 1 second. That much fast our system is. So our intention is to make how much we can reduce this clock cycle, that much fast we can execute. This is the important of the clock cycle. Now, summary is every electronic embedded system is having one circuit that is called processor circuit. It keeps running. Even though our system is in off, okay, switched off, then also the circuit keeps running. That's why the best example, see, you set an alarm in your mobile, set alarm and switch off your mobile, but still it works. Even though our system is off, one circuit keeps generating. That's what the processor circuit. This processor circuit keeps generating the clock signal. Okay, how much the width of the clocks, how many number of clock cycle it will generate in 1 second, that much speed it will do. Okay, so this is about the clock cycle. So now let us see what is the equation for this what? Performance, to assess the performance. Now I written one program. Okay, see, we write some programs. See, some programs may have some 20 lines, some programs may have some 100 lines, some programs may have 700 lines, some program have thousands of lines, different. So let us take, there are n number of instructions. So capital N indicates number of instructions in our program, number of instructions. Now, there are some instructions are there. Let us take an example. So if I say add A comma B comma C, the meaning of this instruction is it will add the content of A with the content of B and the result is stored in C. So that means same thing I will write it as C is equal to A plus B in high level language. I will add the content of A with the content of B and store the result in C. So here, how many operations I am performing in this instruction? So first, A, B, C are the variables. Variables are nothing but the what name given to the memory locations. So first it go to the address A, fetch the value stored in A, one operation. Then similarly, go to the location B, get the value of B, two operation, add this third operation and store the result in C. So totally we need 4 operations. 4 operations to do this one instruction. Similarly, if you take one more example, say, for example, move A comma B. That means the meaning is whatever the value stored in A, that I am moving to the location B. Here how many operations I am doing? Here, so first take the value of A and move to B location. So that means here only two operations I am doing. Let us take one more example. Okay, so I will say increment A. So increment A means what? I am incrementing the value of A by 1 by default. Increment, that's what the increment. So take the value of A, one operation, add 1 to that, second operation, store back to A, 3 operations. So that means in this one, I am doing 3 operations. So that means in some instructions we are performing 4 basic operations, or in some instruction we are performing 2 operations, some instruction we are executing 3 operations. That means different instructions, in different instruction we are having different number of operations. But in one operation require 1 clock cycle. Every operation should get completed in 1 clock cycle. So that depends upon the complexity of the instruction. Some instruction 4 in the operation, some instruction 3, some instruction 2, some instruction may 5. We don't know. That depends on the complexity. Now I will take that S. Okay, that S be the average number of steps. Average number of steps in an instruction. In the number of instruction, in each instruction, let us take average. 1 is 3, 1, 4, 2, 3, average is number of instructions. Then next we'll say clock rate. Clock rate, that means how many number of clock signals I am generating in one cycle. So this R, I can say 1 by P. That means clock rate is what? How many pulse or widths period in 1 per second. So 1 by P. This is the equation. Now, see, suppose, assume, now I done how many statement? 1, 2, 3, 4, 5, 6, 7. Let us take one more 8. There are 8 instructions are there. 8 instructions are there. Okay, 8 instructions are there. 8 instruction. Assume on an average, every instruction is having 2 operations. Every instruction 2 operations. 8. So totally how many clock cycle we need? 8 instruction. In each instruction 2 operations. 8 into 2, 16 operations. So I need 16 clock cycles. So that means I have to multiply what? Number of instructions and with S. So the total time taken by our processor. Total time taken by our processor to complete execution of one program is equal to number of instructions into the average number of steps per instruction divided by clock rate. So this is my what? The basic performance equation of any computer. So hope you understood. Okay. Let us discuss one problem on that. Let us take, this is the problem statement. A program, that one program. Okay. Let us take some program. So it contains some 1000 instructions. 1000 instructions. So number of instructions what? N is equal to 1000. N is equal to 1000. So out of that, 25% instruction requires 4 clock cycles, 40% of the instructions requires 5 clock cycles, and remaining 35% of instruction requires 3 clock cycles. Okay, now we need to find what is the total time taken to execute the program running in 1 gigahertz. That means clock rate is given. Clock rate is 1 gigahertz. So, but that steps we are not taken completely. See, some instructions, that is 25% of instruction takes 4 clock cycles. 40% of the instruction takes 5 clock cycles. The remaining instruction takes 3 clock cycles. So that we need to find out. So now here what? So totally N into S. Totally 1000 instructions are there. So 1000 into S. But S is 3, 4, 5. It's varying. So what I will do? So how many instructions taking 4 clock cycle? 25% out of 1000. So 25% out of 1000 means what? 250 instructions. So 250 instructions are taking how many clock cycles? 4 clock cycles. So 250 into 4. Okay. Plus next 40% of the instruction. 40% means 400 out of 1000. So for 400 instructions taking what? 5 clock cycles. Okay. Next plus remaining. So 40%, 25%, 65%. Remaining is 35%. That means 350 instructions are taking 3 clock cycles. So this is what total N into S. Divided by clock rate. Clock rate is what? Divided by R. R is what? 1 gigahertz. 1 into 10 to the power of 9. So this is equal to what? Now T is equal to. Okay, now T is equal to 250 into 4, 1000 plus 400 into 5, 2000 plus 350 into 3, 1050 divided by 1 into 10 to the power of 9. So this 1000 plus 2, 3000 plus 4050. So this is nothing but 4050 divided by 1 into 10 to the power of 9. So this you can write 4050 into this 10 to the power of 9. If you brought to the numerator, it becomes minus 10 to the power of 9. So I'll put it in minus 6. So 3 digits. Okay. So this is nothing but now t is equal to 4.05. That is I brought 3 digits. Okay. Into now 10 to the power of minus 6. That is nothing but, okay, t is equal to 4.05 microseconds. This is the answer. That means our processor takes these microseconds, 4.05 microseconds to complete a program of containing 1000 instructions. See, 4 microseconds. So this was the performance equation. This is the performance equation in order to assess the performance of our computer. And so one example problem on that. Okay. Hope you people understood. If you have any questions, please write it in the comments. Thank you. Thanks for watching.